Okay, so when we look at question, I want to kind of look over these questions and make sure that, because a lot of people are going to probably want to take the 4 and 5 test over again. Remember, it's a complete replacement grade. So can you guys walk me through what to do with question 1 here? For instance, I know, hopefully you know, because it's arithmetic and because it's finite, that you're going to be, eventually you're going to be using little Carl's formula, which is the number of terms over 2, first term plus last term. I noticed when I was grading it that a few people decided to change this number right here to a 3. And I don't know why they did that when they were taking their test, but that messed up their problem. So hopefully you won't do that. So in this question, out of the 3 things that you need, 1, 2, 3, 2 of them you already know. Anybody tell me what they are? Any of the pieces?
Is A1 6?
Correct. The first term is 6. Okay. Is there anything else out of the remaining 2 pieces? Do we know the number of terms, or do we know the last term?
A1 is 81.
The last term, that's A sub n right there, is 81. So the first term is 6 and the last term is 81. So that information we've been given. The thing that we have not been given is how many terms there are. And so this is when I showed you guys in your notes how you would use the sequence formula, a sub 1 plus d times n minus 1. Okay, so, oops, let me get this moved out of the way. So we had to use 6 plus, now what's the common difference between the terms? How much is it going up by each time? Any term minus the previous one. Any term, it's 5, isn't it? Okay, and so the thing that I showed you guys that you would have to do is you would have to solve this right here in the green box there. And I'm hoping that you would not add the 6 and the 5 because that's illegal, but you would push the 6 over to the other side by subtraction. So that would say 75 equals 5 times n minus 1. And I told you before break that you could distribute the 5 and it would not harm you if you did. I don't typically do that because I just divide it out to the other side. But if you did multiply the 5 through, it would be perfectly fine. You wouldn't have any problems. So how many terms are there?
16.
There are 16 terms. So as soon as you knew that there were 16 terms, then you knew what to do to finish this problem. And so you'd have 8 times 87, and at the moment, let's see, 640 plus 56, 696. That would be the answer to this particular question. Now, and I guess maybe I should ask you guys if do you guys just want me to go one by one through these questions, or do you want to skip to different questions?
Could you go one by one?
Yeah, we can do that. All right, so let's see here. Let's clear this off. So question 2. This is also a finite sum, so what pieces of little Carl's formula do we have? Do we know how many terms there are? When you look at the summation notation, it says that we're starting with the first term and we're stopping with the 60th term. Do you know how many terms there are?
60.
That's right. 60 terms. So we know that much of little Carl's formula. We do not know what the first term is, but do we know how to find it? What should I plug in for n if I want to find the first term? Well, if I want to find the first term, that would be great if I wanted to find the 60th term.
Oh, so 1.
Just a 1, right? Okay. So it's really not that bad. It's really not too hard. But yeah, that's right. That's exactly what you want to do. You want to plug in a 1 to find the first term, and plug in a 60 to find the last term. So when we plug in a 1, we get -1. And when we plug in a 60, let's see, 180 take away 4, that would be 176. So now we have the two pieces, the remaining pieces of the puzzle. I'm going to go grab a calculator while you guys are figuring that out, because I forgot to grab one. I got over 5,000. What'd you guys get? Anybody?
I actually don't have my calculator with me. I don't
Okay.
know where it went.
All right. Well, anybody else? Okay. 5,250, right? Because we have 30 times 175. Okay. But if you, I don't know if anybody was typing that in wrong on the calculator. If you do want to try to type it all in at once, make sure you use parentheses around the 60 over 2. And then you shouldn't have any issues whatsoever. Some people were not using parentheses. I noticed their answers were wrong, even though when I looked at their work, it looked like it was correct. So maybe they're just not paying attention to the videos. I try to be clear on when to use parentheses and when not. Does this look like it's finite or infinite?
Finite.
So those two answers are ridiculous. Now, the next question is it a sequence or a series? A sequence has a bunch of commas in it. A series is when we add things together. So which one is it?
Finite series.
Correct. It is choice C, finite series. I thought that was going to be an easier question on the test than several people made it, but hopefully when they retake it, it'll be easier for them. Okay, let's find the number of terms first, just like we did on question 1. So we need to fill in some of these blanks. Like we need to know the first term. Well, the first term is a 7. And we need to know the common difference between the terms, and the common difference is what? How much are we going up by? Looks
5.
like we're going up by 5. So we want to solve this equation right here, and that'll tell us how many terms we have. So it's very similar to what we did before. We subtract the 7 to the other side. Oops, I evidently cannot subtract. So that would be 55 equals 5n minus 1. And then just like we did before, we would divide by 5. And so how many terms do we have? Looks like we got 12, right? So we need all options that have 12 terms in it. And does that make sense, what we did there?
Yeah.
Okay. Since there's only one person I'm talking to here, which I do appreciate, by the way, because at least I know you're paying attention. Hopefully everybody else is, but so there's really only three choices here: B, C, and D. Now, what I suggested you do before, what happens when you plug in a 1? What are you supposed to get?
The first term.
You're supposed to get the first term, which is a 7, and if you plug in a 2, you're supposed to get 12. And if you plug in a 3, you're supposed to get 17. So we really can kind of test these to figure out what works. So for instance, we can come down, we can go to letter B, and we can do 5 times 1 minus 7. And as soon as we see that that's not equal to 7, we can get rid of that choice. And then we can try letter D, 2 times 1 plus 5. Well, that does equal 7. And we can try letter C, 5 times 1 plus 2, and that does equal 7. So far C and D are both, valid choices. Well, then we can try plugging in a 2. 2 times 2 plus 5, that's 9, which is not equal to 12. Therefore, that is a bad choice. And you would find that it would work over here. You would get 12. So simply plugging in a couple numbers. Now that's not going to get you to the final answer. If you look down here at letter G, it also has a 5n plus 2. So you still need to know how many terms there are. Now, could you plug in, here's an interesting strategy. What if you plug in a 12? What is 5 times 12 plus 2? Well, guess what? That's 62. But if you went down here to this one and did 5 times 13 plus 2, you'd end up with 67, which is not the last term. So you could just plug in the first and the last. That's an interesting thought. I don't know why I didn't think of that before now. But we could do that.
Wait, so what would you do?
You can actually, now, if you plug in a 1, you have to get 7, right?
Mm-hmm.
Well, whatever the top number is when you plug it in has to give you 62.
Mm-hmm.
So letter choice C is the only one. When you plug in the 1, you get a 7. When you plug in the 12, you get a 62. Now, I don't know if there are any other choices. No. Yeah, I literally think that you could find it that way too. You could plug in a 1. Now, if you don't want to do that for all 8 choices, because you just really don't feel like plugging in that many numbers, you can find how many terms there are, just like we did, and then plug in a 1 and a 2. It's up to you. But really you can plug in a 1 for the first one. The problem is you're guessing by plugging in the top number. You just know that if you plug in the top number, you're supposed to get 62. And if you keep coming to like letter choice A, if I plug in 5 times 11 minus 7, I don't get 62. I get 48. So that can't be a possible choice. Does that kind of make sense?
Mm-hmm.
Okay. So we have 26 rows. Okay, so we know that we're adding 26 different numbers together. We know the first one is 15. But we don't know the last one. So we have to figure it out. some of my students were figuring out how many they were doing this, which is half the work. So they were trying to figure out how many seats were in the 26th row, which that's not bad. That's actually good. But then they didn't use it. Now to go from one to the next, it looks like we're adding 2, right? Common difference is 2. So some of my students, when they were taking this test, they did, let's see here, 15 plus 2 times 25 is 65. So they would write down 65 as the final answer. Well, that needed to get used in here. I'm going to have to pause my video for a second because my dog's going to bark like crazy in a moment. So I'll be right with you. All right, so now that we have that information, then we could, so that would be, oops, get my writing tool back on. 13 times 80. 15 plus 65 is 80, and then 80 times 13 gives me 1,040. And if you really want to just plug it into the calculator, just make sure you use parentheses around it and let it do the work. Yeah, I'd have people on the test put 65 as the answer, so I knew that they were on the right track. They just didn't finish the question. But that's the kind of partial credit stuff I had to give to go back and look at their work. Okay. Question 6, write the arithmetic series in summation notation. Okay, so how many terms are there? You can count them right there. How many terms are there?
5.
So I knew that the top number was a 5. And then what I gave credit for was I was looking for you guys to do something like this. And I had to fix this on almost everyone's because Math Excel wants it in a different format. But first term, okay, so first term is 2. And the common difference between the terms. Well, the common difference between the terms in this case is also 2. So, I had students putting this, and they're completely correct. Now, Math Excel wanted them to simplify that, but I don't care. I'll go in and fix those. So, that'd be a good answer for me. If you knew the number of terms, and you can plug in the arithmetic formula. Okay, so that's all, all the questions I'm going to ask from 10.4. And then from the 10.5, let me find my 10.5 questions. And there are 8 questions from that section. Let's try to go through these. Determine whether the following series is arithmetic or geometric. Let's see here. Well, these are all geometric. So that's kind of a dumb question, all right? The reason I say that is because since I'm separating out the test questions, 10.4 and 10.5, all of the 10.5 questions will be geometric. And so what are we multiplying by each time to go from one term to the next to the next? It might actually be easier to use the smaller numbers, such as the 3 and the 5. So what are we multiplying by to go from 15 down to 3?
You're dividing by 5.
So you are exactly right, but you can find it by taking any term and dividing by the previous one. And so that shows you that you are doing exactly what you just said. You're dividing by 5. Okay, so now we know our multiplier. Okay, now, how many terms are they asking me to add up? It says right here that they're asking me to add up 200 terms. And the formula that we said we would use is first term times 1 minus r to the n power over 1 minus r. Now, I'll tell you what I noticed on some people's work that caused them to make mistakes. For some strange reason, and I'll erase this, I'm going to write it in blue, some people put the n on the outside of the parentheses right there. That messed it up. Okay? So that's a mistake I don't want people to make. The other mistake that they made was they forgot these parentheses on the bottom. And by forgetting those parentheses on the bottom, they got the wrong answer. So, as long as you follow this formula, you shouldn't have a problem. My first term is 375. My multiplier is 1/5. Now, if you don't like fractions and you would rather use decimals, then your formula would kind of look like this. Because 1/5 is equal to 0.2. So if you like decimals, nothing wrong with that. Just use the decimal version. And 375, let's see, 1 minus 0.2 to the 200th. And I think this is the one where, 0.2 to the 200th is a really small number. So I got 468.75. But all I'm doing is literally using one of these formulas and using parentheses in the right spots. You're going to be fine. Does that make sense? Tell me if it doesn't.
No, it does.
Okay. All right. So, question 2, we talked about this one. Let's give myself a little bit of space here. We got March, April, May, June, July, and August. So we're going to make 6 payments. We're saving up for a family vacation. It says that our first payment is $120. So that's our first payment. And every time we're going to go to the next month, we're going to multiply that. We're going to raise it by 20%. So what is the multiplier if you raise something by 20%?
0.2.
1.2. Did you put the 1 in front?
No, I'm sorry.
Okay. No, that's fine. I just want to make sure you remember that you're starting with 100% and you're going up 20%. So it's 120% the following month, which is why we need that 1.2. Okay. So now when I go to find the total amount for all 6 months together, first term is 120. And then I know that I have 1 minus 1.2 to the 6th power over 1 minus 1.2. And let's see here. 120, parenthesis, 1 minus 1.2 to the 6th. And then divide that by 1 minus 1.2. I end up with 1191.59. Now, they said that I needed 1330 in order to go on this trip. So I don't have enough money. So I'm going to find out how much I need. 119.1.59. Now they said round up to the nearest dollar. When I subtracted this and this, I got 138.41. And some kids answered that, and I give them complete credit. Math Excel is looking for $139 because they're saying that they wanted a whole number of dollars. It's not that big of a deal to me, but I was looking for people to subtract the two, and that's why I have to go in and give partial credit, because if you put 138.41, then you should get full credit, not you shouldn't be marked wrong at all. So that's why I have to look at the work. That makes sense?
Yeah.
Okay. Evaluate the sum. Okay, so we know the first term, right? It's a 4. We can see that the multiplier is 3 to go from any term to the next one, any term divided by the previous one. So we can see that we're multiplying by 3. The thing that we don't know is how many terms there are. So that's why we had to set this equal to first term times the multiplier to the n minus 1 power. Okay, so this is probably the most difficult question on the test, just because this causes you to go back and think about logarithms. We would have to divide by 4 first, and 2916 divided by 4 is 729, and 729 equals 3 to the n minus 1 power. So then we have to convert it to logarithms. What's the base?
Oh, I don't remember. I don't remember how to do this.
Well, when you look at the statement 729 equals 3 to the n minus 1, there are basically 3 things that you have here. You got the 3, you got the n minus 1, and the 729. When we rearrange them into the log form, one of those green boxes is called the base. Can you tell me which one you think the base is?
729.
Nice try.
Dang
It's
it.
3. Okay. Now, I always told you to find the exponent next, because the exponent goes on the other side. So your choices are 729 or n minus 1.
N minus 1.
Correct. That only leaves you with one thing left, which is 729. Our calculators cannot handle the log base 3, so we use the change of base, where we do log of the argument over log of the old base. In other words, we change it to base 10, and then our calculator can handle it. And so we can do log 729 divided by log 3, and we end up with 6, which means that n has to be equal to 7 terms. If n minus 1 is 6, then n has to be 7. So that means I know what I can put in my formula. I'm looking for the sum of 7 terms. And then I can type on my calculator. 1 minus 3 to the 7th divided by 1 minus 3. And I get 4,372. 4,372. So, did I lose you anywhere in that?
No.
Okay.
I got that.
Good. Okay. Determine whether the infinite geometric series diverges or converges. Okay, diverges means there is no sum, and that would only be true if the absolute value of the multiplier was greater than or equal to 1. Converges happens if the absolute value of r is less than 1, and then we can use the infinite formula. First term over 1 minus r. So we got to figure out which one of these situations we're in. So what is the multiplier? If you take any term and divide by the previous one, I would suggest you start with those two right there. If you take 1/6 and you divide by the previous one, what do you get?
1/6.
Yep. So the multiplier is 1/6. Now, which one of these am I in the converge or the diverge category?
Converge.
Correct. So now we know that we can use the formula. So let's see here. We got 1 minus 1/6 on the bottom. We just need the first term. Well, the first term in this case is a 1. And so now I can type that 1 divided by parenthesis 1 minus 1/6 in my calculator, and I get 1.2. And so that is the correct answer, 1.2. Well, I had some students that were like, they would type in like 1.199. Well, that's just a rounding issue somewhere in their calculator. I don't care about that, you know, so I was able to give them full credit for that. But some kids were just randomly choosing diverges. And I'm like, okay, well, I can't give you credit for that because it's not true. Make sense?
Yeah.
Okay. All right. Evaluate the following infinite series. Okay, so what's the multiplier? Can you look at that and tell me what the multiplier is?
Negative 0.9.
It is negative 0.9. So, when you take the absolute value of that, is that less than 1, yes or no?
Yes.
So that's a yes. So that means I have to use the formula. First term over 1 minus r. Okay, so it's probably pretty easy to see what the denominator is going to be. What are you going to put on the top? What's the first term? If you don't know, plug in a 1. What is negative 0.9 to the 1 minus 1 power?
1.
That is the whole number 1. Good. So I know that's what goes on top. And now I can say 1 divided by parenthesis 1 minus negative 0.9, which ends up being 0.526. Now, you know, Math Excel would probably tell me I'm wrong because it says 2 decimal places. So it was looking for an answer like 0.53. That is not that big a deal to me. Being able to show that you know that it actually adds up to a sum and that you can use the formula correctly, that's what makes more of a difference to me. Okay, question 6. What's the multiplier?
2.
2. Is the absolute value of r less than 1? Yes or no?
No.
That's a no, which means that there is no sum. The series diverges. Never gets close to a single number because the whole thing is getting bigger and bigger and bigger. Okay. How about this one? What's the multiplier? When you look at the formula, can you tell me the multiplier?
5.
Remember, it's first term times r to the n minus 1 power.
Oh yeah, so it'd just be 1.
Well, take a look at this formula here. Which letter or which number represents r?
Sorry, I'm blanking here.
Okay, see how the first term would be 5?
Oh, duh. Yeah.
Okay, so what would r be?
So
What's in the parentheses?
3.
3. So is the absolute value of 3 less than 1? Yes or no?
No.
No. So that means the sum does not exist. Very similar to the last question. Make sense?
Yeah.
Okay. All right, question 8. Last one here. Evaluate the sum of the following finite geometric series. So let's see here. This is not infinite, is it? It is finite. It has a stopping point. How many terms are we adding up?
6.
6 terms, right? Right, 6 terms. So we need the first term. What's the multiplier?
1.
Remember, it's first term times r to the n minus 1 power. What is the r? Isn't it the 1/3?
Yeah.
Okay. So we got a 1/3 there, and we got a 1/3 there. We already know that there are 6 different terms. And how do we find the first term? What do we plug in? We plug in a 1. And so what is 1/3 to the 0 power?
1.
1. So now we know what goes right there in my formula. And so I can figure out what the numerator is. 1 minus. And these parentheses are important, and I can't stress that enough. Some people were completely ignoring them and getting the wrong answer. And I ended up with 1.497 or 498, 1.498. That would be an acceptable answer. If you went to the nearest tenth, you'd put 1.5, something like that. But either one of those answers I'm going to give full credit to. So do you think you're going to go retake that test?
Probably. I forget my score, but I don't think it was anything
Well,
drastic.
I went through and gave all the partial credit, so I put it in the grade book. I would definitely encourage you to go retake that. It would be good for, there's a lot of people that need to retake it. I know this is all weird and different, so I want people to get a good score. And I believe, if I jump back over here, it's not a requirement to do the 10.4 and 10.5b retake tests. Okay, and I wrote that out here. But you have your notes, and right here you have until Sunday night at the end of this week to retake that test. So if you want to retake it, then schedule out the time that you can do that and get that taken. And if you have any more questions, feel free to ask me now or throughout the week. So, do you have any more questions on things?
Just one. Do we have to let you know when we're gonna retake it?
I would just let me know. I would just let me know after you're done. Just shoot me an email and say, "Hey, finished the retake." Now,
Okay.
You do need to take pictures and post them, and I forgot to put the Google form in here, so I'm going to have to do that. I'll have to put the Google form in here so you guys can just, take the pictures like you did and upload them into the Google form so I see your work, and then I can give you partial credit. And then you guys have a couple Ed Puzzle videos to watch before Wednesday. So you guys can get started on those. You could probably get one done before your next class. They're both about 30 minutes long, and that's all I'm asking you to do before Wednesday. So.
Mr. Staley?
Yes.
Is it okay for me to leave to head
Yep.
to work?
Yep, go ahead. Yep.
Thank you.
Yep, just make sure you do those Ed puzzle videos. But
Okay.
yep. So if anybody else if you have questions, I'll be, Miss Hibisky or Miss Lodig, I'll be happy to help you right now. If not, you're more than welcome to jump off the call and get started on an Ed puzzle video, taking notes over those two, because that's all I have for you until Wednesday.